Hi everyone. Now let's look at problem 435. This is non-overlapping intervals. Given an array of intervals where intervals of I equals start I, ni, return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. Note that intervals which only touch at a point are not overlapping. For example, 1, 2, and 2, 3 are non-overlapping. Okay. So let's look at the example 1 there. We have 1, 2, 2, 3, 3, 4, 1, 3. Alright. So I think it's a bit hard to see that there are any overlaps here. So let me try to sort it. So we have 1, 2, we have 1, 3, 2, 3, 3, 4. So if you are gonna remove it so that there's no overlap, then I guess we need to remove the 1, 3 there. And then we are good. So we could just remove one of them and the rest are not overlapping. Correct. Example 2, we have 1, 2, 1, 2, 1, 2. This is sorted, so I guess we need to remove 2 of them because they are exactly the same and they are all overlapping. Example 3, we have 1, 2, and 2, 3. So I think these are all good. So we could keep them and then we don't have to remove anything. Alright, so I think I got the problem. I'm thinking whether there is anything relevant to know. So I would like to clarify a few things. Number 1 is, as usual, we see that the intervals are not sorted, so we know that. And how about the length of the intervals? So it's given by between 1 to 10 to the power of 5. 1 to 10 to the power of 5. Alright, I think we got everything we need here. So I'm gonna do this. So I'm thinking and looking at example 1 there. Basically, we see that 1 and 2 overlap. I think what we need is that, so we see that the start of the second intervals happen before the end of the first one, so there is an overlap. I guess we could remove the one that ends later. Right? Because so that in the future we minimize the, hold on, I think we want to remove the one that ends later. So I'm thinking whether there is a case when you want to remove the one that ends earlier instead. I think there is, no, there is, yeah, because we have sorted it by the start time. So we basically want to end each interval as soon as possible so that another interval can start as soon as possible. So let me replace my wording. We want to remove the intervals that end as late as possible so that the next interval could start as early as possible. So I think I'm gonna put down some note here. First one is we want to remove interval that ends later. So I guess we need to keep track of the previous end time. And then when we compare two interval and then they overlap. So let me put down two there. In case there is an overlap, what we are gonna do is remove one. So we remove the interval that ends later, and then the pref would be the minimum. So pref of 1 would be the minimum, and then we move on. Otherwise, else, if there is no overlap, then we basically set the pref into the current one. Does this make sense to you? Okay, makes sense. So let us try with our example input there. So first one we have pref, and then we have current. Then I think we keep track of what we removed there, just for clarity. So pref we have 1, 2, then 1, 3. So this overlap actually let me just keep track of the end. So and pref, and also whether we remove or not. So first one, the end of pref is 2. So let me just redraw everything here. Okay, so we need to keep track of the end of the previous, and we need to keep track of the current one. Then let's just say we have a count there. Okay, so curve. First of all, we have 1, 2. So the end pref becomes 2, and then we have 1, 3, which is overlapping, so we remove 1. We need to remove something here, and then the end will become the minimum, which is 2. And now we have 2, 3. So overlap here means that the end of pref happens before start of current. Yep. Now 2 and 3 does not overlap, so we update the end of pref to 3, and now we have 3, 4. It also doesn't overlap, so we are good. And now we remove just one of them. Right. So example 2, again we have end pref, we have current, and we have the count. First of all, we see 1, 2, so end pref is 2, then we have 1, 2 again. That one we need to remove. Take the minimum of end, but we see 1, 2 again, so we need to remove it again. So we remove basically 2 of them, which is correct. Sample 3, and pref we have curve. First of all 1, 2, and pref becomes 2, and then we have 2, 3, and we are good. Alright, I am pretty good about this. We start programming unless there is further optimization that you would like me to explore. Okay, so I guess what we can do is can look through all of this. So I'm gonna set the end pref. Right, so we are gonna need end pref there and then the count. So let me just call it the end, and then I'm gonna initialize it to the first of the current. Okay, I forgot one thing. We need to sort it. So intervals dot sort key equals lambda. Here only needed to be sorted by the first one, which is the start. Then the end would be the intervals of 0, of 1. And then we're gonna look through the other intervals, curve in intervals of from the second one towards the end. Actually, in here, instead of curve, we could use start and end. So I'm gonna use left and right to distinguish. So if left is before the end, then we need to remove them. Remove one of them. So count, we increase the count, and then the end would be the minimum. And R. Otherwise, the end would be the right. In the end, we just return the count. Alright, let me quickly go through the code again to make sure I don't miss anything. First of all, I'm gonna sort the intervals. Then I'm gonna keep track of the end time of the previous interval. And then there is a loop there to check through all the other intervals that we have. If the start is before the previous end time, then we need to remove one of them because there is an overlap. So we increase our count. We set the end time to be the minimum of the previous and the current end time, so that we try to minimize, in the sense that we are trying to minimize the possibility of overlapping with the next interval. Alright, so that's what the first if is doing. Otherwise, we just set the end to be the current end time, which is the R. Then we just return the count. Okay, let me test the code with our examples there. So example 1, we have 1, 2. So end will be 2. Now curve will move on to the 1, 3. 1 happened before 2, so there is an overlap. However, we keep the end to be 2 because it is the one that stops earlier, meaning that we remove 1, 3. And as we move on to the rest of the intervals, we don't see any more overlap. So we are good. Example 2, there is an overlap there, and we need to remove 2 of them. Example 3, we don't have any overlap, so we're good. Okay, so let me input our solution to LeetCode. Intervals.short key lambda x is x of 0, just the start. Then the end would be, I'm gonna be more clear over here, so end prep equal intervals of 0 of 1. And now we look through the rest of it. So for start curve, so let's just use start and end. In intervals towards the end, if start is before the end prep, then don't forget to initialize the count to 0. Here we set count equals 1 and thread equals minimum of n thread and the end. Okay, otherwise we set the end thread to the current end. Then we return the count. Try this. Just going to submit it. And yeah, we got it right. However, it looks pretty slow, I would say. But let me try to submit it again. This time it's still 101. Think I better check the solution from other people to learn more. So they still use sort, and then we go through all the intervals. If intervals of the start is before that, then we increase the count. Then this is more or less what I'm doing. How about the 1ms solution? I think it's still the same. Let's try to analyze the complexity. Here we got O n log n. Yeah, because of the sorting. I'm pretty sure we are good here. So let me check some other sources for solution. Complexity is O n log n. Yeah, I don't see any better way. So I guess we are good. So thank you everyone. Because I see all of them requires a sort. So that would basically what is the term for it? How to say? Let me find the correct word to say it. Dominate. So yeah. So the sorting complexity dominates the rest of the logic. Okay, so I think we will stop here. Thank you everyone.